Hello everyone, I, Prof.R.R.Patil from Navasahyadri Education Society group of institutions welcomes you all for the workshop on basics of engineering mathematics. So today we are going to see about the matrices. We will see introduction to matrices. Here we are going to see about matrices, spatial matrices and matrix operations. So first about matrices. A matrix is a rectangular arrangement of numbers in rows and columns. Rows run horizontally and columns run vertically. Element is each value in a matrix. The dimension or size of the matrix are number of rows into number of columns. So this is how we are going to give the size or dimension of the matrix, that is number of rows into number of columns. Find the dimension of each matrix. So now we will see the example how to find the matrix dimension. So here you can see how many rows are there in this A matrix. There are 3 rows and there are 2 columns. So dimension of the matrix becomes 3 into 2, that is 3 rows into 2 columns. Next you can see there is 4 rows and 1 column. So 4 into 1. This is also called as column matrix because there is only 1 column in it. We will see it in spatial matrices. Next you can see there are 2 rows and 4 columns. So it will be 2 into 4. So now spatial matrices. In spatial matrices, some matrices have a special names because of what they look like. So row matrix, then we have column matrix, then we have square matrix, zero matrix and identity matrix. In row matrix, only one row is there. In column matrix, only one column is there. In square matrix, there are same number of rows and columns. Zero matrix contain all zeros and identity matrix only main diagonal elements will be 1 and all others will be 0. So types of matrices, I will give the example of each of the matrix. So first one is the row matrix. So it has only one row. You can see the row, only one row is, if the matrix has only one row, then we call it as a row matrix. Next one is column matrix. It has only one column. So you can see here, there's only one column, example of the column matrix. Next, square matrix. It has same number of rows and columns. So here you can see there is a three number of columns is 3, number of rows is 3. So 3 cross 3 matrix is there. So 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4, etc. are the square matrix. So we can say n cross n is the square matrix. And we can say 1 cross into n is a row matrix, n into 1 is a column matrix, and n into n is a square matrix. So now zero matrix. Zero matrix is a matrix in which all the entries are 0. You can see some of the examples. 3 cross 3 zero matrix. We are writing O 3 cross 3 and all elements will be zeros. Same way, example, second example, that is 2 cross 4 zero matrix. So here also O 2 cross 4 and all are the zeros. A zero matrix is indicated by O and the subscript can be added to indicate the dimension of the matrix. Note here, zero matrices play a similar role in operations with matrices as number of 0 plays in the operation with real number. Means the operations play same role as zero matrix, and the zero matrix in matrices and zero in real number plays a same role. Identity matrix, the n cross n identity matrix denoted by IN, it has n rows and n columns. All main diagonal elements will be 1 and all others will be 0, and it is denoted by I. So I of 2 means 2 rows and 2 columns, and it is given as an example. I3 with 3 rows and 3 columns. Note here, the identity matrix plays a similar role in operation with matrices as number 1 plays in operations with the real numbers. We will see now matrix operations. So first we will see matrix addition. You can add or subtract matrices if they have same dimension, that is same number of rows and columns. To do this, you add or subtract the corresponding element, that is the numbers in the same positions. So here we can see the example of matrix addition. We need to add two elements with same position, like 5 plus minus 11, 2 plus 0, 4 plus 7, 9 plus 1, 10 plus minus 6, minus 3 plus minus 8. So the resulting matrix will be minus 6, 2, 11, 10, 4, minus 11. We subtract. Now here is the example of subtraction. Same way as that of the addition. That is 7 minus minus of 3, 3 minus 0, 5 minus 8, 9 minus 1, 11 minus minus of 3, minus 2 minus of minus 4. So here the resulting matrix will be 10, 3, minus 3, 8, 14, 2. So next, we cannot add or subtract if both the matrices don't have the same order. Like it is not possible to subtract matrices or add matrices that do not have the same order as the example. Like here we want to add 2 cross 3 matrices matrix with 3 cross 2 matrix with 2 cross 3 matrix. So this is not possible. We should have the same dimension matrix, like it should be either 2 cross 3 or 3 cross 2, but both should be having the same dimensions. Scalar multiplication. To do scalar multiplication, multiply each entry in the matrix by number outside, which is called a scalar. This is like distributing a polynomial to a distributing a number to a polynomial. Scalar multiplication, 4 into 2 minus 4, 5, 0, 1 minus 3. So here it will be 4 into 2, 8, 4 for the 60, 4 into 5, 20, 4 into 0, 0, 4 into 1, 1, 4 into 1, 4, 4 into minus 3, that is minus 12. So resulting matrix will be 8 minus 16, 20, 0, 4 minus 12. Matrix determinants. Now we will see how to find the determinant of the matrix. The determinant is a real number associated with the matrix. Only square matrices have determinants, and it is denoted by det of A, or like double slash, double parallel lines will be there. In that we are going to write the A. So that will be denoted by for the determinant, finding the determinant of matrices. So here is an example. I want to find the determinant of matrix A. So how it will be? That is A into D minus B into C. We'll see the example of it. To find the determinant of 2 cross 2 matrix, multiply diagonal 1 and subtract the product of diagonal 2. So here we can see 3 into 4, that is 12, minus of minus 2 is equals to 14. Thank you. Please like the video, subscribe the channel. Thank you very much.